What do we get on top? 0? What do we get on the bottom? 0. What's 0 divided by 0? Undefined, right? That's undefined. This is undefined. Why is it undefined? What makes this undefined? You can't divide anything by 0. A 0 on top does not make something undefined. If this was 0 divided by 4, that'd be 0, wouldn't it? You can have a 0 on top. You can't ever have a 0 on the bottom, right? That's what makes that undefined. So what we're going to do, we're about to get into the notes right now, is we're going to see, and this is what kind of started the whole conversation with calculus, was is there a way to get around this somehow? Can we get around this? This is a problem, right? We don't know how to define this, but is there kind of like a way we can still somehow get around that idea of 0 over 0? Let me give you one more thing. This might make that make a little more sense. Do you all know the definition of average speed? The average speed of something. So like let's say you drove here today, right? You started driving, you went a certain distance, right? And it took you a certain amount of time, didn't it? So your average speed is your total distance divided by your total time. So let's say you drove 30 miles and it took you an hour, right? 30 miles in 1 hour, you average 30 miles an hour, right? What would be your speed at an instant in time, though? I mean, your average speed is like your total distance divided by your total time. But as you're driving, right, you can look down at your speedometer and you can see your speed, can't you? So what would the speed of something be at an instant in time? So I'm going to put here instant speed. What would that be? Well, same definition, distance over time, right? What's wrong with this, though? At an instant in time, how far have you gone? You're not moving, right? Like it's almost like if I'm jogging here, right? And I say right there, right there. How fast am I going? Right there. Well, at that frozen moment, I'm not moving, right? So there's no distance. And how much time goes by in an instant? No time, right? So you get this 0 over 0 idea, right? Which is a problem for us, isn't it? But we know that when we look at the speedometer, it gives us a speed, doesn't it? So this right here is actually one of the first leading questions into Cal 1, which is there a way to define the speed of something at an instant, as opposed to an average speed where you have to have a certain amount of distance divided by a certain amount of time? That kind of makes sense to you? Like, is this even possible? And we're able to do it with calculus. So who came up with calculus? Anyone know? Who actually came up with calculus? I mean, human beings did it, right? But not Einstein. Anyone know? Wasn't Greek? I don't think Newton is Greek. No, I'm pretty sure Newton's not Greek. Isaac Newton, right? Isaac Newton is the father of calculus. So he basically went to school. Imagine this, right? You go to school, you absorb all the math that's known, and you say, that's not enough. I'm going to go make up my own stuff. I'm going to go create my own math. And he went and basically worked in a shed in his backyard and created calculus from nothing. Not nothing. I mean, he used other people's results, but the ideas were fresh and new, right? And then there was another guy, last name is Leibniz. He came up with calculus independently of Newton. It's kind of amazing that in the history of humans, two people, independent of one another, created the same concepts at the same point in time in history. And the way they did it was they used different approaches. And you'll see in this class that we will use, they both had their own notation, because imagine you're making up your own math, right? So you get to like use your own notation, make up your own stuff, right? So We'll use Leibniz notation sometimes. We'll use Newton's notation. I'll point it out when it happens. But those are the two people that sat down and figured this out, all right? And it's all based, the heart of calculus. I'm going to draw a heart. It's going to be cute. Okay, here's the heart of calculus. That is pretty good heart. The heart of calculus is something called the limit, all right? The limit. This is it. All calculus, Cal 1, Cal 2, Cal 3, all the calculus sequence is all born, and many other math subjects are all born from this idea of the limit. Everything that you've done in math up to this point, everything you've done has been finite. Do a computation, and at some point it comes to an end, right? There's been this it's hard to explain because you haven't seen the idea of the limit yet, so you don't know how to distinguish the two, other than me telling you that the limit, what we're going to do is we're going to allow things to become repeated, processes that go forever. We're going to have ideas that are really strange to us, like let's let something get really, really small. And you're like, well, what do you mean small? And I mean small. And you're like, well, how small? 0? And I'm like, not 0, just small. So we're going to have these things called infinitesimals, and these things that processes that repeat, over and over and over and never stop. Okay, that's something different for us, and it's all based on this idea. All right. So this is what Newton was able to come up with. So our first section in our notes, our first chapter is called limits, and the first section we're going to do is called the limit of a function. So I go, day 1 of Cal 1, I like to jump right into this, all right? We're not going to review stuff. You can go do that on your own. Let's get right into the heart of calculus, the limit. One more disclaimer before we officially begin here. One more thing. I teach this class as if you're going to take Cal 2, all right? It's called Cal 1 because there's the implication that there's a 2 to follow, right? So my job is to prepare everyone here for Cal 2 to be successful. Have you all heard about Cal 2? What have you all heard about Cal 2?
It's basically the reverse of this. Like you're finding...
Oh yeah, it's like basically Cal 1 you're learning how to walk. And in Cal 2 you learn how to walk backwards. Okay, but like moonwalk, it's all badass, right? So, all right. Anything else you heard about Cal 2?
It's harder.
It's harder.
I heard that they go into more different dimensions, I guess, like not just the 2D.
Yeah, Cal 3 is where you go into higher dimensions, but in Cal 2 you could argue, yeah, you do some three-dimensional stuff. So, how many of you need Cal 2? A lot of you, right? So when you get to Cal 2, right, no matter how bad things get in here this semester, when you get to Cal 2, you're going to wish you were back in Cal 1. You're going to wish you were. Cal 2 is tough, all right? It's a tough, tough class. So my job is to prepare you for that, right? It makes no sense for me to lead the sheep to slaughter here, right? I mean, my job is to make sure you are ready when you walk into Cal 2 to do well in Cal 2, to succeed, all right? So keep that in mind. That's why the bus will keep moving, all right? It's your job to ask questions. All right, we're going to talk about the limit of a function. The good news about this first section, it's very visual. It's very visual, all right? It's almost so easy to see for most people that they're like, well, what's hard about this, all right? So if you feel like that, that's good, all right? This first section should feel that way. What I'm going to do is I'm going to show you a function, all right? There it is. All right, there's the function. I'm going to just jot the function down over here so you can see it. It's not important what the function is. I just want you to know that that is the graph of this function. That is a polynomial function, right, from college algebra. Looks like polynomial. And what I'd like to do is I'd like to ask first from the graph here, if you can tell me what f of 2 is. Can somebody just raise your hand? Raise your hand, and or else I'll call on you. Can somebody tell from the graph what the value of the function is at 2? What you got? 8, yeah. Do y'all see it? So if you go to 2 on the x-axis, right? So when I say f of 2, I'm saying replace x with 2, and then tell me here what the y value is. So I'm looking kind of like an ordered pair, right? Plug in 2, what comes out? When you plug in 2, what comes out is that point, and that's at 8, right? So the x-coordinate is always your left and right. Your y-coordinate is always your up and down. Clear? Anyone disagree? That's good? Okay. That is not what calculus is about. That's easy, right? That's easy to do. Here's what calculus is saying. I want you to, oops, I did that the wrong way. I want you to ignore, completely ignore what's happening at 2 now, all right? I'm covering it up so you can't see it, right? And I'm not interested anymore about what's happening at 2. I want to know what's happening near 2. All right? So what is the function's value near 2, x equals 2, sorry. What is the value of the function near x equals 2? Anyone want to go out on a limb and tell me what they think? So what would be someone give me a value of x that would be near 2. So give me something close to 2. What? 7. Oh, you're looking at the y. I'm saying give me an x value that's close to 2. 1, 1.5. So someone said 1, right? That's pretty close to 2, right? Yeah. 1.5 is a little closer, yeah. So let's start with 1. If you said 1, what would the value of the function be at 1? What does it look like? About 3, right? If I go to 1.5, what's the value? Somewhere around 6, right? So what I'm asking you to do is this. Imagine coming in from the right-hand side, right? If your x value is 1, your y value is 3, right? And 1 is close to 2? I see some people saying, could I get closer to 2? Let me get closer. 1.5, right? Now look at your y value, 5.62. Could I get closer to 2? What would be real close? 1.9? It's pretty close, right? Look at the y value. What is it? 7.581. What is happening as my x value gets closer to 2? What is happening to the y value? Where does it appear to be headed towards? It's heading towards 8, isn't it? It's not there yet, is it? It's not there. I'd have to get closer. Let me get a little closer. 1.91. 1.99. Look at 1.99. I'm pretty close to 2 now, right? And I'm getting closer to, that's closer to 8, isn't it? Let's go even closer. 1.999. 7.996. I'm getting closer to 8. You can see it visually though, can't you? I mean, you can see the graph is headed towards 8, right? Can I get closer? What would be closer? 1.999, 4 nines? What would be closer? 5 nines? 6 nines? See, we run into this. This is the first part of calculus where you're like, because when I said near 2, what do you mean by near, right? Like, am I close to you? Are we close? Are we near each other right now? Yes? But what about my mouse? My mouse here. I'm more near this, right, than you? But how about SeaWorld? Am I near SeaWorld right now? Compared to the sun, am I near SeaWorld?
Yes.
See, there's a problem with the word near, isn't there? It's relative. So this is our first place. It's not like college algebra or pre-cal. Like we're talking about something that's a little more abstract here. Like you could argue, someone right here could argue that 1.999 is actually really, really far away from 2. And I would agree. You could argue that. Because how many numbers are still between 1.99 and 2? How many numbers are still in there? An infinite number of numbers are still there. There's still an infinite number of numbers that I could keep. 1.9999, 1.9999, 1.99999. I could do that forever. I'm never going to get to 2. Does that make sense? It's kind of weird, yes? Okay. Now when I said near 2, right, I asked you to discuss the behavior of this function near 2. What we're going to say here is this. From the left, because you came in from the left, didn't you? You said, I'm going to start at 1, then 1.5, then we got closer, right, to 2? From the left, the function approaches 8, right? As we come in from the left, the values of the function get closer and closer to 8. We can see that visually, yeah? But what about from the right? Can we approach 2 from the other side? Yeah? What would be a number we could come in on the other side from? Let me get this out of here. Give me a number on the other side. 3? Okay, let me bring this in here. So here we are at, let me go back to a 10. So what's the value of the function at 3? Can you all see from that? 9, right? If that's any better. Right? So here we are at 3, we're at 9, right? Let's get closer. What's going on here? Oh, oops, wrong one. 2.5, where are we? 9.38. So it went up and now it's coming back down. Let's get closer. 2.1, oh look, 8.379. We're getting closer to 8, aren't we? And then let me just get right to it. Oops, I should have done this. I think you get the idea, yes? Okay. Right here, this question right here, we never wrote it down. This right here is college algebra. That's a college algebra question. What's the value of the function at 2? 8. That's college algebra. Calculus is about what's happening as you approach from both sides, left side and right side. What is the function doing? All right? The calculus question cares nothing about what's happening at 2. Nothing. Only about what's happening from the left and right. Let's do another example. All right? This example is pretty straightforward from the picture. Shoot, where is it? Close your eyes for a second. There we go. I'll take it out. There we go. Here's another function. And I'm looking at 2 again, and I just want y'all to understand that for these examples, I've chosen 2 to be the number that we're going to look at. Just for convenience, it's going to be 2 on most of these examples, but it could have been any other value. All right? So let me ask you first the college algebra question. What's f of 2? Who's going to volunteer? What's f of 2? What's the value of this function at 2? 8? Why are you saying 8? Make that a little bit bigger. Yeah, so at 2, you come up and you look, you see the open circle here? That means it's not that's not the y value. You go up, you see it's solid, that means that that's the y value. So the value of this function at 2 is 8. All right? Got it? All right. Let's play. I'm going to call some names here. I'm going to call people I don't know. How about Emily? Is Emily here? Emily, hey, how's it going, Emily? Good, good. Emily, I'd like for you to look at this graph, and can you tell me what appears to be happening as we approach 2 from the left-hand side? What does the function appear to be headed towards? So, Emily, I want you to imagine you're like walking on this function here, okay? And you're moving from left to right, and you're trying to get closer to 2. And I want you to tell me about how high off the ground. That's basically what I'm asking, right? Okay, it increases, right? To what y value are you getting closer and closer to? 8, right? You see that? Yes? Okay, everyone see that? From the left, I'm just going to put here from the left, we're going towards 8, right? As we approach 2 from the left, we're approaching 8. Good. Let's see, Melanie? Good. Any questions first? Okay, how about from the right, Melanie? This one's a little bit harder. Approach 2 from the right, which means imagine you're standing here and you're walking, right? And you're trying to go towards this x value. Tell me about the height of you on that function. What is it approaching? Take a shot at it.
It wouldn't be 4, right? Because
It would be 4. Exactly.
an open circle?
But okay, so you're saying, Melanie, right?
Yes.
Melanie's saying, but wait a minute, it's an open circle. Remember, this is a calculus question, right? And when it's a calculus question, you do not care about what's happening at 2. You only care what's happening near 2. Understand? So you're walking here and you're getting closer and closer to 4, even though you never actually get to it. Everyone understand that? It's irrelevant that there was an open circle there. It's completely irrelevant. All that's relevant is that you were getting closer and closer and closer to 4 as you approach 2 from the right-hand side. So from the right, you're approaching 4. Any questions? So the value of this function, I'm going to take this out of here again. The value of the function, see, that's the college algebra question right there, right? That's college algebra. Ignore everything except what's happening at 2, your value is 8. The calculus question is, okay, now ignore what's happening at 2 and tell me what's happening as you're coming in from both sides. So college algebra, calculus, from the left, from the right. Next example. So I'm hiding things now from you. But I'll bring it back. I'll bring it out. There's the graph. All right, first question goes to, oops, Hector. Did I call Hector? Hector? Okay, how's it going, Hector?
Good.
Any questions?
No.
Okay, Hector, first the college algebra question. What is f of 2?
6.
6, everyone agree? You plug in you plug in 2, open circle, you ignore it. There it is at 6, right? And then that's an open circle as well. What if we had 2 solid dots? What if we had 2 solid dots instead of 1? Could that ever happen? Could it? What would it fail to be if that happens? Remember that test in college algebra? The vertical line test? It wouldn't be a what? A function, right? If it fails the vertical line test, you draw a vertical line, if you hit more than once, then it fails the vertical line test, therefore it's not a function. In this class, calculus, we talk about functions. So that's never going to happen, so you don't have to worry about that. Okay, good? Hector, yes? Hector, you want to do the next one?
Sure.
Okay, let's come in from the left. Where are you headed from the left?
That's 8.
You're headed up to 8, right? Everyone see that? You're approaching 2, you're coming in from the left. Here's Hector walking along this function, headed up towards 8. Never actually get there, right, Hector? You never get there because it's an open circle. But this is calculus. The limit is the idea that you're getting close to something, near something, seeing what's happening, what's the behavior, right? It's not about what's happening exactly at that point. All right, next one. Alan?
Yeah.
Okay, Alan, you doing all right?
Yeah.
Okay, how about from the right?
4.
4, everyone good? Coming from the right. This is approaching, right? You're headed down there. That value is getting closer to 4. You actually never get there, but that doesn't matter. So from the right, you're approaching 4. So the function's value at 2 is 6. The function's value as you approach 2 from the left is 8. And the function as you approach 2 from the right is 4. All right, this one is harder to see, but I'm going to help you on it. That is 2. It's hard to see this, but that's 2 right here. Okay? That tick mark right there, that's a 2. So let's see. Amanda? Where's Amanda? Amanda, how you doing?
Good, you?
Good, good. All right, any guess as to college algebra first, right? What is the value of the function at 2? By the way, if I call on you and you don't know, right, we're all going to like laugh at you, and after class we're going to all meet when you're not around and like, right, make fun of you. No, I don't want anyone to have any sort of like pride in here, okay? Everyone just, you make mistakes in class, right? That's fine, right? You want to make your mistakes and learn from those mistakes. Especially, you know, in calculus, you're going to have to learn to fail in order to succeed, right? You're going to have to be able to fall, get back down. I mean, get back down, get back up, right? Stay down. All right, so if I call on you, you don't know, it's okay, no shame. We move on, where no one's going to care, all right? I'm not implying you don't know.
Thanks.
Take a guess, though. What's the problem? What's hanging you up here? At 2, what? Do you see any? Nothing, right? There's no dots anywhere. That's an open circle. Y'all see that? So the function is, they haven't given me information, right, about what's happening at 2. So it's what? What is it? Undefined. It's undefined at 2. There's no dot. All right, that's kind of a tricky one. So this is not, we'll say undefined. Now it's undefined at 2, right? It's undefined at 2, but how about this idea of the limit from the left and right? Do we have that? Well, let's see. How about from the left? Now, this is where it's hard to see it, okay? It's hard to see it, so I'm going to have to help you. This right here, oh, I went too far. That's about -1/4. That's the y value there. So do you all see that as if you come in from the left, that we're actually headed to that y value of -1/4? And as we come in from the right, we're headed to the same place. Do you all see that? From both sides, we're headed to the same value, aren't we? So I'm just going to tell you that's what it is. You're just going to have to take it on faith a little bit here. From the left and from the right, we're headed to -1/4. This is the first time we've had this, right? We've never had an undefined, but from the left and from the right, we have something, right? Right? We haven't had this. This is the most important case right here. I'm going to go back, all right? I'm going to go back for a moment. Let's go to Desmos. Are y'all familiar with this software, this website? Software, it's not even a software, it's a website. If you're not, you should get acquainted with this. Really, really powerful software. What I'm going to do is I'm going to graph that function that I kind of motivated this idea with. Remember that? Remember I put that up earlier? I said, hey, what happens when you plug 2 into this? And we said 0 over 0 would get undefined, right? So when we graph this, at 2, we should see an open, like a circle, shouldn't we? There should be nothing there. So I'm going to type x squared minus 4 divided by, nope, divided by x minus 2. There's the graph. What the heck's going on here? At 2, what does it look like the value of the function at 2 is? What does it look like from the graph? It looks like 4. But if you take your mouse and you click on that, watch what happens when I get to 2. Oh, right there. See that? Let me see if I can't. Yeah, I can't do it. I got to keep my mouse there. Do y'all see at 2 it says undefined? And now it put an open circle there? I to this day don't know why they haven't figured out how to put an open circle there on their own. As powerful as technology we have and as much as this can do. This thing, when you type that in, don't y'all agree it should just have the circle there? Like by now they should have figured that out. They haven't, I don't know why. So, and this is the same problem you run into with your graphing calculators. If you graph this on your graphing calculator, you're not gonna know that there's a hole there, but there is, all right? So there is a hole here at 2 that the computer's not showing me, right? So I cannot plug 2 into this function. However, what does it look like happening from the left? From the left, let me see. Jordan? Where's Jordan? Hey Jordan, how you doing? What do you think? From the left, where's this function headed? As we approach 2. We're approaching 2, right? And we're walking along here. And you're getting closer and closer. Where are you headed towards? Negative? Negative 4 would be down here.
Towards 4.
Towards 4, right? So your height's headed towards 4. So from the left, you're headed towards 4. How about from the right-hand side? If we come in from this side, we start approaching 2 from the right. Now we're walking here, and we're walking along here. What's our height? 4 as well, right? 4 as well. So what does this mean? I mean, like, what's the whole point of this? The whole point is that we have a function that at 2 it's undefined, right? At 2 it's undefined. But near 2, right? If I plug any value in that's really close to 2, I'm getting an answer that's really close to 4. And this goes back to that idea of the running, right? And saying freeze, right? You can't talk about the speed at that moment because it's 0 divided by 0, understand? But there's a way to figure out what would happen if I was near, right? That I can get an answer. Now, I haven't laid this out explicitly for you, but I'm just trying to motivate the idea that this is going to be, this idea of the limit coming in from both sides is the way around the 0 over 0 that Newton was able to figure out. How we doing? Y'all all right? First day back? Okay, let's keep going on our notes. This one is a different one because I want you to look at what's happening at 0, not at 2. So let's see if we can all answer together, all right? What's the function's value at 0? Undefined. So here's -1, here's 1, here's 0. So the function's value at 0, it's an open hole, undefined. So f of 0 is undefined. What happens as you approach 0 from the left? Where are you headed?